Hey guys, welcome back. So this is the second video on finding the missing angles in this diagram. So previously I've shown you different ways that you can use the triangle angle sum theorem, which I'm going to pull it up. So this one right here, the triangle sum theorem, and also the exterior angle theorem. Okay, so I'm trying to pull it up right now, right here. Okay, so this image is actually a combination of that. So you can use either or to solve all of these angles that they're asking for. Okay, so let's begin. So the first clue is to always start where there's a straight line, because you know a straight line is equal to 180 degrees. And if you have a linear pair where you know one of the angles, then you definitely know the other angle, right? So I have two options here. I can either start where angle 7 is or angle 6 is. It doesn't matter where you start off, you'll still get the same exact answer. Okay, so I'm going to choose angle 6 first. So if you notice angle 6 and 103 degrees, these two are linear pair. So to get angle 6, you have to subtract 180 minus 103. Okay, and so you will get 77. All right, so angle 6 is 77 degrees. Okay, the measure of angle 6 is 77 degrees, so that is one of them. All right, now angle 7. You can either say that because you know angle 6 is 77 degrees, and you know that this angle missing this one, you know for sure is 60 degrees, together makes a triangle with this angle 7. So you can use the um, triangle sum theorem, okay, which I'm going to show you, but you can also use the exterior angle theorem. So you know that this exterior angle, 103 degrees, is the sum of these two remote interior angles. Okay, so whatever this is 60 plus this angle 7 together makes 103. So you could do it that way, right? So the measure of angle 7 has to equal 103 minus 60, so I can get the leftover angle 7. All right, I'm going to show you this way, and I'm going to show you the other way as well. All right, so that becomes 3 and 4, so that is angle 7 is 43 degrees. So the measure of angle 7 is equal to 43 degrees. Now let's use a different theorem called triangle angle theorem. So we know that angle 6 is 77 degrees. Okay, if I add 77 and 60, I get 137. Okay, and if I subtract 180 minus 137, I should get 3 and then 43. So as you can see, whether I use the exterior angle theorem or if I use the triangle angle sum theorem, you still wind up with 43 degrees. Okay, so let me erase this, and this. And now we know two angles. See, we're working. All right, so measure of angle 7 is 43. All right, now I can actually move on to the rest of them. So angle 5 is vertical angles with angle 6, so I don't need to do much. I can just say angle 5 is equal to 77 degrees as well. Okay, all right. Now angle 4 and angle 5, or angle 4, angle 5 and 43 degrees make up a triangle. Okay, or you can use again an exterior angle theorem here, right? These two are the remote interior angles. So either way, again, will get you there. So I'm going to use the exterior angle theorem here. So to get angle 4, I have to subtract 103 from 43 because this is its remote interior angle, and that's how I can get angle 4, right? So that's 60 degrees. Okay, so angle 4 has to be 60 degrees. Okay, now we're working to get angle 3. Angle 3 and angle 4 are vertical angles, so angle 3 has to be 60 degrees as well. 60 degrees. Okay? All right, we're getting there. Okay, so now these two make up 90, all right, and then they make up this largest triangle that you see. So if these two make 90, then the leftover angle here is also 90 degrees. That makes angle 2 also 90 degrees. Okay, and again, I'm proving that because there's evidence that this has to be 90. Sometimes it looks like it's 90, but it's not always a right triangle. Okay, so now I know that the measure, let me change that color. Okay, so now I know that, the measure of this is 90, so 2 also has to be 90. Okay, and now we go to angle 1. All right, so if this is 90 degrees and this is 145 degrees, I can use the triangle angle sum theorem, or I can use the external angle theorem, so exterior angle theorem. So if this is 90 degrees, then 90 minus 45 is equal to the measure of angle 1. So the measure, let me change colors again. All right, so the measure of angle 1 is equal to 90 minus 45, so which is equal to 45 degrees. All right, I hope that helps. Let's see if you can figure out this next one. Okay, so this is a multiple choice, so they want to know the measure of angle 5. So try to use a theorem and try to work where you know at least one of the angles in a straight line. Okay, try to pause this video. Okay, so if you're ready to hear the solution, here it goes. All right, so I like to start where there is a straight line. I know a straight line equals 180 degrees. So that means the measure of angle 2 has to equal 180 minus 40, which equals 140 degrees. All right, so I know angle 2 is 140 degrees. Now they're looking for angle 5. So I now know that angle 2, the measure of angle 2, I can use the exterior angle theorem to say that that's equal to 60 plus whatever the measure of angle 5 is. Right? So in order for me to get the measure of angle 5, I have to subtract 60 from whatever the measure of angle 2 is. So we know by substitution the measure of angle 2 is 140, and 140 minus 60 is 80. Okay? So 80 degrees is the measure of angle 5. So that's letter C. You might have done it in a different way and definitely got the right answer, and that's very possible. Okay? And that's the joy of it. Thank you for watching. Have a great day.